Hello, welcome to video number 50. This is about combining like terms. I'm Mr. Miller, and I have a very special guest today.
Hi, I'm Alfredo, and I'm a senior, currently taking AP Statistics with Mr. Miller. About my experience, I'm gonna talk about a little bit about my experience. I was actually in geometry class my freshman year of high school, and I took Algebra 1 in 8th grade, so that was a really big help for me. Freshman year, I really didn't think about the classes that I was gonna be taking in the future, but then after a while, I started actually thinking about what classes that were available, and I was thinking about taking calculus junior year and taking stats senior year. So for those of you guys do you have any freshmen that are?
There are a couple.
Oh, that's really good. It's really helpful for you guys. My college experience, not yet, but my scholarships that I've been applying to. I don't know if you guys have heard of Posse, but it's a full tuition paid scholarship. I was a finalist for that. Sadly, I didn't get the scholarship, but I'm currently working on another one called Gates, and that one's a full ride scholarship. It pays for your room and board and your tuition as well. And it's the hard part about that one is that you have to do 8 essays.
Oh wow!
Yeah,
But full ride, that's
Yeah,
unbelievable
worth
value.
it.
You're talking
It's
over
worth it.
$100,000 probably.
yeah, and it's pretty much any college that you choose to go to. So it's
All
really
right.
good.
Foreman students do it. You were a finalist in the Posse, which was really good. Foreman students do it.
Yeah.
And so, if you're a sophomore, this is going to come even more quickly. So, just around the corner, you can take a dual credit class next year, pre-AP, Algebra 2 and pre-calc, and stats in a calc class senior year,
Yeah.
and start applying for these scholarships. So, my point is, hopefully all this math pay off quickly for you.
Hopefully.
All right, let's do it, Alfredo.
All right, let's start with the first one.
Okay, so here we go. For our first slide here, when it comes up here, there it
Okay.
is. We are very familiar with the left side, combining
We are.
like terms. We can combine X terms and numbered terms. The last problem C has A's and B's. We know that we can combine terms that have the same variable part. And what we're going to learn is we can simplify expressions with square roots the same way.
Yes.
When we're adding or subtracting expressions with square roots, we can combine ones that have the same radical part. All right, Alfredo's going to get us started
All
here.
right.
So on the left side, this goes way back, and we're going to have to hit pen. So hang on, I'll edit this part out. Let me borrow that for a second, I forgot. So I'll edit this part out, so that's kind of in our way here. So we got to go, that's my bad. View? Is it view? No.
Oh, it was right there. It was start inking. Yeah.
Review? Yeah, how did I lose this? Start inking?
Okay, that's it.
And then,
All right.
all right, it should be working now. All right, here we go. We're going to work on the left side first.
All right. So for the left side, we have 2x plus 7x. You could just do 7 plus 2 is 7, 8, 9. And then you do 9x for that one.
Very good.
And then for the next one is 8x minus 19 plus 2x. How I used to solve these problems, I just focused on 8x and 2x, and I would just add both of them together. So I would get 10x and then just add the 19.
Very good. So the 8x and the 2x are like terms. The minus 19, we're kind of just stuck with.
Yeah.
Okay, how
Same.
about this one?
It's pretty similar to the one we just did. 6a and 2a. 6 minus 2a, 4. 4a. And then for the 8b, it's minus 8b.
All right, very good. Now these look a lot uglier
Yeah.
because square roots look intense, but it's really the same idea. We're looking for ones that have the same radical part.
Yeah. So what I used to do, I used to take the radical treat it as a variable. It can be 2x, but instead you just replace it with the radical.
Yeah.
So you just do the outside as you would with 9x. So it'd be 9, and instead of x, you put radical 19.
Right, it's the same idea. Actually, on the one on the left, x just represents a number.
Yep.
We just happen to have the square root of 19 as our number. So these are really mathematically the same thing. The 2x plus 7x, 2 times square root of 19 plus 7 times square root of 19.
Exactly.
Kind of the same thing. One has x, one has square root of 19. All right.
And so for the next one, same thing. 8 radical 10, 2 radical 10. Add those two together, and it'd be 10 radical 10, and then minus 19.
Yeah. Okay.
And then for C, is 6 radical 3 and minus 2 radical 3.
Mm-hmm.
So it would be 4 radical 3 minus 8 radical 10.
I still have my Christmas decorations up. Look at that. Okay, so all right, now that would be great if that was all there was to it, but sometimes you have to simplify the expressions first.
Mm-hmm.
So that's why we practice simplifying so much. That's going to come up a lot. That's like
Yeah.
the most important idea, because everything we do with radicals almost always involves simplifying at some point.
Anything related with math is
Yeah.
simplify.
So square root of 8, we can simplify that. We can break that up into square root of 4 times square root of 2, and then plus. And you don't have to, I kind of, the way I do it is I kind of replace everything with it broken up
Mm-hmm.
and then simplify. So
Okay.
that would be square root of 25 times the square root of 2. And now I'm going to simplify the square root part. That would be
Alright.
2 square root of 2 plus 5 square root of 2. And we lost our square root sign there.
Oh,
That's
okay.
our pen does that
There you
sometimes. All right. Now, we simplify and we look. Are they like terms? We
Yep.
said they both have square root of 2, so now we can combine them.
All right. So 7 radical 2.
Very good. All right. 27. What perfect square goes into 27?
9.
Got it. Square root of 9
All right.
times square root of 3. And then we're going to do
The same thing.
minus.
And then we have 4.
Yep.
We have 3.
He's still got it. In stats, we don't do anything like this, but
Mhm.
you still got it. Minus 2 square root of 3. All right. That's going to be 1 square root of 3. We can still
Mhm.
go on the side
All
there.
right.
That's still visible.
1 radical 3.
Very good. Now, if they weren't like terms, we'd be done. So we
Yeah.
can only combine it if they end up being like terms.
And then you can write this as just radical 3 as well, right?
Sure.
Correct? Right.
Yeah, even more simple.
Equals. There you
Good.
go.
Okay, we're getting there. So what goes into 75? Which perfect square?
That's
Yeah, 1, 4, 9, 16, 25.
let's try 25.
Yeah.
All right. 25 times 3,
Uh-huh.
and then we lost the 3 there.
Yeah.
And minus 25 as well.
Right.
Radical 2.
And all this is just simplification.
All right. Let's simplify 25 to 5 radical 3
Uh-huh.
minus 5 radical 2.
All right. We take a step back.
Mm-hmm.
When you look at them, can we combine those two?
We cannot.
Right. So we just walk away, Alfredo.
Just
There's
leave it
nothing
like
else
that.
we can do here. All right. It's kind of annoying, but there could be 3 terms, 4 terms, any number of
Yeah.
terms, and the strategy is the same, simplifying. So that first one, we're going to do square root of 4 and square root of 6. And then plus 9 and 6.
Mm-hmm.
And then plus, I guess, 9 and 2.
Yes.
Okay, so we got 2 square root of 6. And then 3 square root of 6. And then 3 square root of 2. So we got 3
Ooh.
terms. 2 of them we can combine.
Yeah.
And 1 we're stuck with.
So 2 and 3.
Right.
5 radical 6 plus 3 radical 2.
Man, you must practice this on the side to keep sharp. Alfredo told me after calculus, everything is easy after calculus.
Yes,
so
it is.
things just click. That's a good thing. In calculus, you take a step like that, all the things you had before them kind of fall into place and get easier.
Mhm.
All right, now you guys got to be totally good at square roots.
Yeah,
So this is a little bit more challenging still.
it is.
So the reason why is that square roots have a number in front. So the first one is 7 times square root of 20.
Mhm.
But we just break up square root of 20 like we normally would.
Just ignore the 7 for now.
Yeah, well, actually, now I like to write it. So write 7
Alright.
because square root of 4 times square root of 5. And then plus. I'm going to do the same thing. I'm going to keep the 6 and then square root of 9 times square root of 5. And you can do it. I see people do it a variety of ways.
Mhm.
That's just my style. I like to keep everything
Yeah.
there so I don't lose anything. Now, square root of 4 is
2.
2. And so 7 times 2 is 14. Or we can put 7 times 2.
7 times 2 and then radical.
Oh, there's 7 went away anyway. 7 times 2 times square root of 5. This pen's really hard to write
Yeah.
with. plus 6 times 3 times square root of 5. Alright, so we just placed the radicals. Now we can multiply. We can do the 7 times 2 part in the first one. That's 14 square root of 5 plus 18 square root of 5. Now, can we combine?
Yes, we can.
Yeah. 32.
32?
Yeah.
32.
I hope so. Send us an email if it's not. Wow, that's impressive. So you can go through all that, that's good, but it's kind of like very detail oriented. You gotta be really focused while you're doing each step.
Yeah.
First step, we just replace the square roots, then we simplify them, then we combine like terms.
And I would just suggest when I used to do these problems, just write each problem down so you don't, like you said, don't lose any number or any radical.
Yeah, just carefully writing, following step by step.
Yeah, and then after a while you start, finding shortcuts to it.
All right, man. Alfredo, I love having you here. Go for it, man. Anyway, just kick back and watch this last one work here.
4 and then 63. Break that down to 9. Radical 6.
Oops, 7.
7.
That's all right.
And then minus 5. Radical 4. Radical 7.
Yep.
Plus. Which ones are those?
16.
16. This is 16.
This is tough. 80 is tough, but 16 is the largest perfect square that goes into it.
No,
And then 5. All right, here we go.
4, 9. 4 times 3 radical 7
Yeah.
minus 5
You get 8
Times
plus for
3.
showing your work here.
plus 4 radical 5. Is that correct?
Yeah.
Okay. And
So
break that.
now we're still simplifying. All right, one of these is not like the others.
Which one? 7, 7, 5. Ooh, that one.
Yeah.
So we simplify this one over here. So we get 2 radical 7 plus 4 radical 5. That was a bad circle.
That's all right. It's good math though. So to be ready for calculus, pre-calc will do that, but you just gotta get very fluent at these things. So next year you'll be practicing square roots will come up again and many other things. So pre-calc really goes through many things, and just so you can kind of do these things without thinking about it after a while, it comes automatic, and that's what you need. You can be successful in calc.
Yeah, master these skills for radicals. Then you get to imaginary numbers and it gets crazier. But
yeah,
don't worry about that.
We'll talk about that later this year. They're kind of cool.
Okay.
All right, so here we go. It's time for the journal assignment.
Journal time.
So the first two have to simplify a little bit, and then the last one is like the last slide, where a little bit more challenging. But in all three, have to simplify them first and then combine like terms.
Yeah, don't get intimidated by that 200. It's easier to break down.
Oh yeah,
That's all.
I'll let them figure it out.
All right.
They'll be okay. Thanks, Alfredo.
Yeah, no problem.
Next time.